everybody. In this video, we're going to talk about how to add and subtract mixed numbers. So let's first talk about what a mixed number is. So whenever you have a fraction that's greater than 1, there's two different ways you can represent it. So one way is you can represent it as an improper fraction, where the numerator or the top of the fraction is bigger than the bottom of the fraction or the denominator. So in this case, we have circles that are split up into 5 equal pieces. So the number of pieces in the whole is 5, and the number of pieces that we have is 13. So this would be an improper fraction that represents this amount. But we could also represent it with a mixed number, which is basically a mixture of a whole number and a fraction. So when we look at it as a mixed number, the way we think about it is we think about it as being 2 wholes and 3/5. So this improper fraction and this mixed number are the same amount. They're just two different ways to express the same amount. And the way that you convert improper fractions into mixed numbers is you divide the top by the bottom. So we'd say 13 divided by 5. 5 goes into 13 2 times. 2 times 5 is 10. We subtract that and we have a remainder of 3. So basically what this is saying is that we can make 2 wholes and then we have 3 of the fifths left over, which is how you get 2 3/5. And if you want to convert a mixed number into an improper fraction, you basically think about the whole number as being a fraction. So you say, okay, well, how many fifths are in the number 2? Well, there's 5 fifths in one whole, so in 2 wholes, there would be 10 fifths. And if you do 10 fifths plus 3/5, that gives you 13 fifths. And so that's how you can convert between improper fractions and mixed numbers. And we're going to talk about how you can use this to help you add and subtract mixed numbers. So let's say that I was adding the mixed numbers 3 5/7 and 2 4/7. Well, since I'm combining these two amounts together, I could just combine the whole number parts together and then combine the fraction parts together. So if I take 3 wholes and I add 2 wholes to it, that's going to give me 5 wholes. Then if I do 5/7 plus 4/7, that's going to give me 9/7. However, this isn't a typical mixed number because 9/7 is actually 1 whole and 2/7. Because if I were to take these two pieces right here and add them in over here, that would give me an extra whole, and then I would have 2/7 left over. So I'm going to think about this as being 6 2/7. And that's the way that I would add those mixed numbers together. You can also kind of think about it as carrying if you want to. So you could kind of think about the fractions as being a place value. And if you do 3 5/7 plus 2 4/7, and you add your sevenths together first, well, 5/7 plus 4/7 is 9/7, which is the same thing as 1 whole and 2/7. So you could carry that whole to the whole column. And then 1 whole plus 3 wholes plus 2 wholes would give you 6 2/7. So that's another way you can think about it if you like doing it that way better. And this can be really useful when you're subtracting mixed numbers. So if I had the number 5 1/3 minus 3 2/3, well, I can do just 5 wholes minus 3 wholes. That equals 2 wholes. However, doing 1/3 minus 2/3 is not possible because 1/3 is smaller than 2/3. So one way that might be helpful to think about this is with the place value model, where you say, okay, if I have 5 1/3, and I want to subtract 3 2/3, well, I can't do 1/3 minus 2/3, so I could borrow from my wholes, which leaves me with 4 wholes, and when I convert one of my wholes into thirds, that gives me a total of 4 thirds. And so this would become 4 thirds, and then I could subtract the fractions, and I could say, well, 4 thirds minus 2 thirds gives me 2 thirds. And 4 wholes minus 3 wholes gives me 1 whole. And I could show that visually by taking away 2 thirds from my fraction part, and then I could take away 3 wholes, and the amount that I have left is 1 whole and 2 thirds. So that's one way you can subtract mixed numbers, even if the fraction in the first mixed number is smaller than the fraction in the second mixed number. But another way you could also solve this problem is with the equal additions method that we learned when we were talking about how to do mental math with whole numbers. So the way that the equal additions method works is you add the same amount to the amount you start with, as well as the amount that you're taking away. Because if you add extra stuff to the thing you start with, but then you take away extra stuff, it ends up balancing itself out and you end up with the same result. So the way that we would do this in this problem is I would add 1/3 to both parts. So I would say, okay, well, 5 1/3 plus 1/3 is 5 2/3. And if I do 3 2/3 plus 1/3, that gives me the whole number 4. And this problem is much, much easier to solve because if I do 4 2/3 minus 4, well, that just equals 1 whole and 2/3. And so the equal additions method can be really useful when you have the first fraction that's smaller than the second fraction. And then sometimes you'll have mixed numbers that have fractions with different denominators. And so when that happens, you need to follow the rules for adding and subtracting fractions, which says that the size of the pieces that you're adding or subtracting together need to match. So in this case, you would think about 1 1/3 as being 1 2/6, because if you multiply the 3 by 2 and the 1 by 2, that's basically splitting up these thirds into 6. And the reason you would want to do that is because the second fraction also has a fraction that has 6 as well. And so you could think about it this way, and then you could say, okay, well, 5 6 plus 2 6, that would be 7 6, which would be 1 1/6. And then if you add that 1 whole plus this other whole and these 2 wholes, you would have 4 wholes and 1/6. So you can do it that way, or another method you can use is to convert the fractions into improper fractions. So the way you would do it in that way is you would say, okay, well, if I have 1 1/3, well, 1 is 3/3, and if I combine that with 1/3, that would be 4/3. And then for 2 5/6, well, 2 is 12/6. And if I combine that with 5/6, that's going to be 17/6. And then once you have the improper fraction form of the mixed number, then you can find common denominators and add them together. So in this case, I would multiply by 2 to get a common denominator of 6. And that would equal 8 6 plus the 17/6. And if you add these together, 8 6 plus 17/6 would be 25/6. And 25/6, if you take 25 and divide them up into groups of 6, well, you'll have 4 wholes and you'll have 1/6 remaining. So you end up with the same answer either way. And it just kind of depends on which method you think would be easiest for the problem that you're given. So you can either make it so that the fractions have common denominators and add them together like we have on the last few examples, or you can convert both of the fractions into improper fractions and add those together. So that's how you add and subtract mixed numbers. If you have any questions, let me know.